All right, we're on 6.5 properties and applications of matrices. Okay. This is a fairly easy section also. So we're gonna learn matrix notation. We're gonna talk about how matrices are used in social networks. We're gonna talk about some different scalar multiplication, finding the matrix product, and using technology, which is optional, but we're gonna make it a strong suggestion. Okay. So first off is matrix notation. How do you read a matrix? Okay. A lot of times in textbooks, they use subscripts to read a matrix location. How it works, remember RC cola? It's always going to be the row times the column. So when you're identifying an element of a matrix, you're going to tell me what row and column it's in. Does that make sense? So this is element A11 or A1, comma 1. This is element A12 or A1, comma 2. Okay. What that tells me is the row it's in and the column it's in. Okay. So I'm in row 1, column 1. Row 1, column 2, row 1, column 3, row 1, column 4. Does that make sense? That's how you read elements in a matrix. Easy enough? Okay, again, most times you're going to see it denoted as a integer versus writing the commas. Why? Because mathematicians are efficient, not lazy. So we're going to eliminate a character whenever we can if it's not going to make a difference in the problem. Okay? All right, so here, if I asked you to identify element A12, what would you tell me A12 is? And why is it -1? Exactly, it's in row 1, column 2, so A12 is -1. What about B32? It's going to be -2 because it's in row 3, column 2. Remember, it's RC cola. RC cola, it's always the row, then the column. Okay, B22. And it's going to be 6, row 6, column 2, row 2, column 2. And that makes it 6. Okay, yes. Okay. Why is it important to be able to identify the elements? Is so that when you're operating, you know what you're plugging in for your operations. Okay. So if I'm computing A11 times B11 plus A12 times B21 plus A13 times B31, can I do that if I know how to identify the elements? Yes. So I'm going to pause and you're going to do your best at computing. So identify the elements and plug them in. All right, what is A11? 0. What is B11? What's A12? A12 is -1. What is B21? Row 2, column 1. What was A13? 6. And what was B31? 7. So the math here, we have 0 minus 2 plus 42 equals 40. For multiplication? Oh. All right, if possible, find a value for x that makes a equal to b. I could find a value for x, but would a equal b? Why not? What's the problem? So even if I said x equaled 6, right? That would fix here, but would it fix that the fact every element has to equal to each other, and A31 does not equal B31. Does that make sense? So therefore, matrix A cannot equal matrix B. Yeah? So if you said x equals 6, you would have been right if A31 it was equal to B31, and they are not equal. Do we see that? All right. How do you feel about basics of matrices? Elements, matrix elements. All right, now we're talking about adding and subtracting, okay? Adding and subtracting matrix is fairly easy. All you're doing is adding and subtracting each element. to its corresponding element. All right. I only can subtract A11 from B11. Does that make sense? I only can add A11 to B11. I cannot add non-corresponding elements together. Yes? Is that doable? All right, so let's go through really quick. So for example, your matrices have to be the same size. Are our matrices the same size? Yes, they are both 3 by 2s, 3 rows, 2 columns, correct? And now we're going to element to element. So 4 plus 3 is 7. -1 plus 3 is 4 plus 1 is -5 plus 0 is 1 plus -2 is, and 0 plus 4 is, and that is your matrix addition. That's it. Yes? Are we okay with matrix addition? Yes. All right. Do you think it's going to change if I go the other way? No, it does not. Just because I now say B plus A, because addition is commutative and has the associative property, doesn't matter the order I added. No, it does not. 2 plus 3 is the same thing as 3 plus 2. So whether I switch it around or not, it's going to be the same. Yes? All right. Now, order matters when you are subtracting. Does that make sense? Order matters when I'm subtracting. So now I'm subtracting every element. So when I'm subtracting, if it says A first, that means I'm doing 4 minus 3. And 4 minus 3 is 1. -1 minus 3 is -4. 4 minus 1 is -5 minus 0 is 1 minus -2, and 0 minus 4, -4. Okay? A minus B is not the same as B minus A. It's going to be different. There is not a commutative property for subtraction, only for addition. Okay? So now we're going to do multiplication. Are we good with addition and subtraction? Which one? Yeah, okay, whatever you want. 3-1. Which one? 3-1. 1 minus -2. A negative times a negative is a positive, so it becomes 1 plus 2. Got it? All right. Now we're going to talk about scalar multiplication. Okay, that means you are multiplying the matrix. What that means is that you're applying this multiplication to every element inside of the matrix. So you are basically distributing. Does that make sense? That's what scalar multiplication is another version of what I like to call the Oprah property. Okay, you get a 2, you get a 2, you get a 2, we all get 2s. Okay, it is just distribution. All right. So really quick, if it says that I have A and it wants me to multiply matrix A by -2, I am multiplying every element by -2. So we end up with what's going to be our new matrix. 2 times -2 is -3 times -2 is -1 times -2 is 0 times -2, 3 times -2, -4 times -2, -1 times -2, 6 times -2, and -3 times -2, 6. Oh my gosh, y'all are so great at scalar multiplication. How do we feel? Great. So addition, subtraction, multiplication, scalar multiplication, we're good with. Okay, don't be mad at me. Do we need more practice if we're good? All right, just making sure addition only applies if the matrices are the same. Could I add these together? Yes, why could I add them together? Because they both are 2 by 3. We can add. Huh? If they're not the same, then there's no solution. Yep. All right, next here it says, do we need to practice multiplying again? No, we're good. We all are comfortable. Cool. All right, now what happens when you combine the two? Where you're going to multiply and then add or subtract. Okay, I said don't get mad. I said that before. Because if you're going to get mad here, you're going to get a little bit more mad the more I keep going. All right. All right. So now we have both skills. We're good, right? We can add, we can subtract, we can multiply. Now, boom, they're friends. We're going to do both. I believe in you. You got this. All right. We're going to do both. Okay. How you do both is up to you. If you want to go through and multiply first and then do your addition, that's cool. If you want to do both at the same time, guess what? That's also cool. Which do we want to do? Yeah. We're going to multiply first. So matrix A is going to be multiplied by 2 and matrix B is going to be multiplied by -3. Do we see that? Why did I say -3? Because I'm subtracting, right? I'm subtracting. So then when I'm done, all I have to do is combine. Make sense? All right. So my new matrix for A is going to be 2, -4, 10. Then we have 6, -8, -2. Yes? Plus my new matrix for B is going to be 0, +3, +15, +9, -3, -6. And now I'm going to combine. Because I multiplied by the negative. So I've already handled the fraction. Right? So now we're going to combine. 2 plus 0 is 2. If you wanted to subtract in the end, then you will multiply by +3. Yep. -4 plus 3 is -1. 10 plus 15 is 6 plus 9 is -8 plus -8, -3 is, and -2 plus -6 is -8. Now, was that terrible, you big crybabies? No. It was not. It was not. Y'all just wanted to complain for no apparent reason. So can we do both? Yes, I knew you could all along. All right, now, remember I told you you're going to keep getting mad at me? I told you you're going to keep getting mad at me. I warned you you're going to keep getting mad at me. Now, we just did addition, subtraction, and scalar multiplication. We're now going to do matrix multiplication. Okay? Matrix multiplication works a little bit different. All right? Matrix multiplication, your matrices do not have to be the same size, but they do have to have a common connection. Okay? We just did scalar multiplication, which means that I just multiplied a matrix times just a coefficient, a constant, a number, right? Now we're going to take two matrices and multiply them times each other. So A times B is what we're looking at, okay? Now, we're going to learn what I call the smile rule. Got it? First, you're going to determine what are the dimensions of the matrix. So the dimensions of this matrix is what? It's a 4x2. So we have matrix A is a 4x2. What is matrix B? Bless you, bless you. It is a 2x3. They can be friends because they're smiling. Okay? The number of columns in the first matrix has to be the same as the number of rows in the second matrix in order for them to multiply. Okay? So they pass the smile test. So the dimensions of my matrix are going to be a 4x3. That's what their product is going to be. All right? Now, if you look at matrix C and matrix D, we're going to test to see if they pass the smile test. Obviously, I told you they did it because I put a big X over it, but I'm going to tell you why. So here we have a 4x2, and this one we have a 3x5. Do they pass the smile test? No. Sad face. They do not pass the smile test. So that means that there is no product matrix. I cannot multiply these two together. It's just the inside. It's just the columns of the first, the rows of the second. Okay? So you see how they're happy? We're happy. We're matrices. Okay? They're happy. But I will allow you to use a calculator. Okay? We're going to model it the long way, but I will allow you to use a calculator in the end. I still have to show you how to do it without a calculator. All right? So when you're doing matrix multiplication, you are multiplying and you are adding at the exact same time. All right? You are multiplying and adding at the exact same time. So I don't know why. I just thought we're gonna go through this first. Okay, so when you look right here, I'm gonna multiply A times E plus B times G. That's gonna be my first new element. Okay, yes, you got this, guys. All right, this is the rule that you're following. Okay, so you're multiplying and adding. So you're multiplying every element in this row to the elements in this column, and you're adding their products together. Does that make sense? So let's look at it with numbers. So for example, I'm going to multiply 1 times 6. So I have 1 times 6 plus 2 times 5 plus 3 times 4. And that's my first element. And I will simplify that when we're done. Make sense? Now we're going to do the next one. B and G. Because this was a 4 by, it's going row, column, row, column. Okay? Then you're going to do the next one. Row, column, row, column. Okay? You got to do it by all of it. So we're going to go again. So we already did this row. And now we're going to, we already did this column. Now we're going to do the same thing to get our second element. So now we're going to do 1 times 3 is there. 2 times 2 is there. 3 times 1 is there. So my new elements 1 and 2 are done. Now I'm going to do this one. I'm going to repeat row, column, row, column. Okay. So we have 4 times 6 plus 5 times 5 plus 6 times 4. That makes my third element. Now I'm going to do my fourth and final row times the last column. 4 times 3 plus 5 times 2 plus 6 times 1. And that's going to make my 4. I use what's called the line method. The line method makes sure that I'm hitting each one the exact number of times. So if I have 2 columns, I know that I'm going to be using this number twice. So did I use it twice already? Yes. So it's just me marking that I've used this number already twice. And then you clean it up. So 1 times 6 is, 2 times 5 is, 3 times 4 is 12. So we have 6 plus 10, 16 plus 12, 28. Now we're going to do 1 times 3, 3 plus 4, 7 plus 3, 7 plus 3, 10. 4 times 6, 24, plus 25, 49 plus 10, 59. And then our last one, 12 plus 10, 22 plus 6, 28. So that is your answer. 28, 10, 59, 28. It's just multiplying and adding a lot. Okay? Multiplying and adding a whole lot. All right, we're going to do another one. We're going to do another one as a collective. Okay. Have kids, they say. Somebody told me. Somebody told me to have a kid. All right. Next, are we ready to try it together? Okay, we're ready to do it together? I find these to be very fun, by the way.
I see.
I don't know why. I think they're fun. All right. So first you got to determine, does it pass the smile test? Okay. So I got to know the dimension. So I'm going to do A times B. A is a 3 by 3. Yes. B is a 3 by 2. Does it pass the smile test? Yes. So my product is going to be a 3 by 2. So I'm going to be making a 3 by 2 matrix. I'm going to have 3 rows and 2 columns. Yes. All right, here we go. So I have 2 times 1, 2, plus 1 times 2 is 2, plus -1 times 3, which is -3. That's first element done. Okay, now we're going to go on to the next one. So I have 2 times 0, which is 0. 1 times -1, which is -1. -1 times 1, which is -1. Second element done. First row done. Now I'm on to my second row. So let's do blue. So I'm going to do 0 times 1 is 0. 2 times 2 is 4. 1 times 3 is 3. Okay. Need another color. I have 0 times 0 is 2 times -1 is. And then I have 1 times 1 plus 1. Done. We're on our last one. Our last row. So we have, meant to choose blue. There we go. Or red. Let's do red. So I have 3 times 1, 3, 2 times 2, 4, -1 times 3, -3. And then last, 3 times 0, 2 times -1, and then -1 times 1, -1. I hit 2 rows, correct? Notice how I have my 2 lines, and I hit 3 columns. So everything is complete. I created a 3 by 2. I do the math, and that is my product matrix. So 2 plus 2 is 4 minus 3 is 1. 0 minus 1 minus 1 is -2. 4 plus 3 is -2 plus 1 is 3 plus 4 is 7 minus 3 is -2 and -1. And that is your product. Okay, it's just a lot of row times column sum. But again, the math isn't the hard part. It's just remembering the pattern. Okay, and it's every element in the row times every column in the other one. And then you find their sum. Every element, every row, find the sum. Every element, every row, find the sum. Okay. However, if it doesn't pass the smile test, guess what? You don't do anything. So we knew that A times B worked. Now we're going to do B times A. What are the dimensions of B? 3 by 2. What are the dimensions of A? 2 by 3. So would this one work? Oh, I'm on the wrong one, y'all. Thank you. This one worked. I was like, that is not what we did. So here, I'm going to test B times A. So B was a 3 by 2. A was a 3 by 3.
No.
This is sad day, no product. And why is there no product? It did not pass the smile test. Okay. All right. So on this one, B times A passes the smile test, but with A times B. So I have a 2 by 3 partnered with a 3 by 2. Does it pass the smile test? Yes, so both of these products would exist. Does that make sense? This product would make a 3 by 3. This product would make a 2 by 2. 2 by 2, 3 by 3. Okay? Now, you're probably like, oh, miss, is this going to happen every single time? Yes, it does get that way. But continuing on with the practice. Now we're going to get to, what if I don't want to keep doing all of that, right? The multiplying, the adding, the multiplying, the adding, the multiplying, the adding. It's not hard mathematically, but it becomes tedious, correct? And I get that. Well, this is beneficial if you plan on going into coding. So if you ever plan on being a computer engineer, computer science, going into coding, this is your bread and butter. It's figuring out these codes and these sequence orders, okay? We're not going to dive deep into it, but we are going to get to the part of how do you do it in the calculator? Probably where y'all are wondering, right? So in the calculator, you're going to go through the steps of putting in your matrices. You're going to have to put in both matrices, your A and your B. Okay, once you have put in the matrices for A and B, then it just becomes normal operation. You're telling it what you want it to do with A and B. Do I want to add and subtract A and B? Do I want to multiply A and B? Okay, do I want to square A and B? You're just going to put it in and then follow those steps. Okay, I'll give you a moment to write down or take a picture, and then we will model the calculator. So I'm going to grab my handy dandy calculator. Here's Sylvie. Again, if you need to borrow a calculator, you can, but please don't take the ones in the class because I'm responsible for them at the end of the year. And Miss Jones does not have $110 for every calculator that goes missing. It's not cool. So I'm going to reset second plus 712. I'm going to input my matrix. So I'm going to go to second, x to the negative 1. I'm going to go to edit. And I'm going to put in matrix A. Matrix A is a 3 by 3. I'm going to input its values, 2, 0, 8, negative 1, 2, 5, 9, 1, and 0. Okay, I'm going to go back to second matrix, second x to the negative 1. And I'm going to input matrix B. So this time I'm going to go to arrow down to 2 for B. And again, I'm creating another 3 by 3. I'm going to input its values, negative 3, 3, 4, 0, 2, negative 3, negative 1, 2, negative 1. Okay, both have been inputted. In order to calculate, you have to be on the calculator page. So to get to the calculator screen, we're going to press second mode. And now we're at our calculator screen. I want to find the product of A times B. So I'm literally going to go to second matrix. There's my matrix A, my 3 by 3, my matrix B, my 3 by 3. I'm going to pick A. And then I'm going to go back, select B. And I'm telling the calculator, I want you to find the product of these two matrices. I hit enter, and it finds the product of those two matrices. And that's the calculator. Ta-da! There's really nothing else to tell you there. Okay? If you input a value wrong, you will get the wrong answer. Pretty obvious there. If your matrices can't be multiplied, it's going to tell you error, error, right? Because they can't be multiplied, and that tells you that it failed the smile test, right? Questions about using the graphing calculator? No? None? Okay. You also can do the same thing with multiplication and addition. So if I wanted to add these two, or scalar multiply. So if, let's say I want to know what is 3 times matrix A. 3, go back to the matrix, click on matrix A, hit enter, and it will multiply the elements of matrix A by 3. Okay, if I wanted to add these two together, so if I wanted to know what is matrix A plus matrix B, second matrix, I'm going to do 1 plus second matrix plus B. It will add the two matrices together, and it says, here are your two matrices, okay? As long as you inputted the matrices, you now can use the calculator to manipulate them. Make sense? All right. So that's what the rest of it is telling you, is that you can use the calculator to multiply and add and subtract, and that is all